Blockchains are all the rage in this day and age. But the billion-dollar question is, what exactly is a blockchain? In this video we will be telling you the use cases of blockchain and how does a blockchain work. A blockchain is a distributed, decentralized public ledger. In basic language, it is just a chain of connected blocks that encloses some information. It consists of two parts, block and chain. Block refers to the digital information stored on a chain, which represents a public database. This decentralized immutable system was initially defined in the year 1991 by a couple of computer researchers and scientists. The decentralized system was originally designed to timestamp digital documents, which made it impossible to backdate or corrupt the documents. It is similar to writing some information on a piece of paper, then writing a date on the paper with non-erasable ink and then laminating the piece of paper. Now, if any corrupt player tries to write a new date on that piece of paper, it's impossible to do that, because of the lamination. However, the decentralized system went almost unnoticed and unused, until the year 2009. In 2009, it was adapted by Satoshi Nakamoto, to create the digital currency or digital asset, which today we know as Bitcoin. Now, the term Satoshi Nakamoto itself has a story behind it. There is a lot of speculation behind this name. Some say it is an individual while others say it's a team. Some also say that it can either be some government or corporate body. But nobody knows his true identity. Now, coming back to blockchain, it is a distributed database which has records or digital information, and this digital information or records are called blocks. A blockchain is a ledger that is entirely open to anyone. Anyone can see the transactions happening on a particular blockchain, but still can't tamper them. So how does that work? To understand that, let's take a closer look at a particular block of a blockchain. Each block consists of some information or data, the hash of that particular block and the hash of the preceding block of the blockchain. Now, the data that is kept inside a block is dependent on the particular sort of blockchain. For instance, the data stored is different in Bitcoin and Ethereum blockchains when compared to each other. The Bitcoin blockchain stores the details about a transaction, such as the sender, receiver, and amount of cryptocurrency. The second element of a block is the hash. Now, a hash is similar to a fingerprint. Similar to the fingerprint of a human being, hash is constantly unique. It identifies a block and all of the information inside it. Every time a new block is created, its unique hash is calculated. When some information or data inside the block is changed, the hash will also change. Hashes play a major role in detecting changes to a particular block. In other words, if the fingerprint of a block changes, it no longer remains the same block. The third component of each block is the hash of the previous block. This efficiently generates a chain of blocks, and because of this technique only, a blockchain becomes so secure. Now, let's take an example to understand more. Here we have a chain of two blocks. Each block in the chain has a hash and the hash of the previous block. Block number 2 points to block number 1. The very first block in any blockchain is known as the Genesis block. Now let's assume that someone tampers with the first block. This changes the hash of the first block as well. In turn, that will make block 2 and all following blocks invalid, as the subsequent blocks no longer store a valid hash of the earlier block. Hence, changing even a single block will make all subsequent blocks invalid. It is to be noted that using hashes alone is not sufficient to stop tampering. Computers in this era are quite swift. They can calculate millions of hashes per second. Now, coming to the security of the blockchains, blockchains secure themselves by being distributed. For managing the chain, blockchains use a peer-to-peer network instead of using a centralized entity. Whenever a new member joins this decentralized network, he gets the full copy of the blockchain and hosts the full copy. The node can use this copy of the entire blockchain to verify that all the things are still in order. Now, let's discuss what happens when somebody generates a new block. That newly created block is sent to every person or node on the network. After that, each node verifies the new block to make certain that it has not been tampered with. After the checking is done, each participating node adds the block to their own blockchain. All the nodes in this peer-to-peer network create consensus. The nodes, together, make a decision on the validity of a block. The blocks that are altered will be vetoed by other nodes in the P2P network. As soon as consensus is reached between the nodes, the new block is attached to the blockchain. And reward is distributed between the validating nodes, in terms of cryptocurrency. In order to fiddle around with a blockchain, one has to take control of more than 50% of the peer-to-peer network, which is almost impossible to do without anyone noticing. What is proof of work? Proof of work is a mechanism that decelerates the formation of new blocks. Now consider that one tampers with a block and recalculate all the hashes of other block to make the blockchain valid again. To get rid of such a situation, blockchains have something called proof of work. For example, in Bitcoin blockchain, it takes around 10 minutes to calculate the required proof of work and then add a new block to the chain, thus effectively decreasing the speed of new block addition. This mechanism makes it very hard to tamper with the blocks. Now let's compare a traditional bank transaction with a blockchain transaction. Let's suppose Ricky has to pay Pamela a sum of $100. Now $100 has to be debited from Ricky's account and $100 will be credited to Pamela's account. This is a classic example of traditional banking where both the parties involved have to trust the bank. Now let's see how this transaction works in Bitcoin blockchain. Suppose we have a public ledger where anyone can see a line as well as add a line. But to add a line, the person needs to have a public key and a private key. Using these keys only, the nodes verify the transaction. Now suppose Ricky requests a $100 transaction. This transaction is then broadcasted to the P2P network. Then the miners validate the transaction by spending computing power. After that, a new block is formed by combining the transactions. Then, the new block is added to the preceding blockchain. This way, the transaction is done and Pamela receives $100 without interference of any central authority like a conventional bank. The transaction gets verified when all the nodes reach a consensus and there is no need of bank or any other middleman. That is why it is known as distributed trustless consensus. Being distributed or decentralized means neither a person nor a bank or a company owns this. A lot of people have this common misconception that use of blockchain is only limited to Bitcoin. Well, it's not true. Blockchain as a technology is emerging day by day and has multiple use cases. Some of these use cases include voting, identity verification, food safety, supply chain, tax collection, and crypto banking. Now it's time for a short quiz. Do give your answers in the comments below. Bitcoin is based on which blockchain? The options are permissioned, private, public, or proof of stake. Thank you for watching and stay tuned for more.